Hello, and welcome to section 1.8, which deals with the real numbers. At the end of this section, we are going to be able to simplify square roots, expressions with square roots, identify the difference between integers, rational, irrational, and real numbers, locate fractions and decimals on the number line. So let's go ahead and get started. First of all, to understand what a square root is, we need to understand what it is to be squared, okay? So remember, when a number is multiplied by itself, we can write it to the power 2, and that's read squared. So in this case, this is 8 to the power 2, which is read 8 squared, and the answer is the square of 8. So again, 121 is the square of 11, because 11 squared is 121, okay? So let's see here, 1 squared is 1, because 1 times 1 is 1. Okay, 2 squared is 4, 2 times 2 is 4, right? 3 squared would be 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, and so on. You can fill this in. This would be 81, 10 times 10 is 100 today. 12 times 12, 11 times 11 is 121, 12 times 12 is 144, okay? 13 squared, 169. Okay, 14 squared is 196. And then 15 squared is 225. Okay, and then as you can see, negatives squared also become positive. Okay, so if squaring is kind of like the function or the operation that takes you from one number to the other, square root is kind of going backwards, okay? So let's say, for instance, here, you have, this are the parts of the square root. You have the radical sign. This m, or whatever's being taken the square root of, is called the radicand. We don't really use that word a lot, but just so you know. So let's see, how does this work? So if m is equal to n squared, then square root of m is equal to n. So let me show you an example. So if here 1 squared is 1, going backwards, square root of 1 is going to give you back to 1, okay? So if I take 2, I square it, that's 4. So squaring takes it this way. Then the square root of 4 is going to take me back to 2, okay? So square root of 1 is 1. So basically, what number times itself is equal to that radicand? So square root of 4 would be 2. Square root of 9 would be 3. So notice these are the same numbers that we just filled out, right? So this would be 4, 5. So these are common square roots, right? 8, 9, 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169, 13. Square root of 196 is 14. Square root of 225 is 15, okay? So really familiarize yourself with them because you will see these later, okay? So let's go ahead and do some. We've already filled out the table in the back, so we can just, go from there. So this square root of 25 would be 5. Square root of 121 is 11. Square root of 36 is 6. Square root of 169 is 13, okay? Square root of 16 is 4 because 4 times 4 is 16. Square root of 196 is 14 because 14 times 14 is 196. So here, the negative of square root of 9 is just negative 3. And then here, the negative of the square root of 144 is just negative 12, right? Because the opposite, or you could think of it as the opposite is outside of the radical. So it just kind of carries over. Okay, so up to this point, we talked about, we talked about counting numbers. Counting numbers are the numbers that you can count on your hands and so on. Whole numbers are the counting numbers, but including 0. And the integers are all the whole numbers, but then also the negative numbers, okay? So you have the counting numbers, their opposites, and you have 0. That is called the integers, okay? So remember the difference. Now, what's a rational number? We introduced a rational number. It's a number that is of the form p over q, which means you can express it as a fraction, okay? Where p and q are integers, and of course, q is non-zero. And a rational number can be written as the ratio of two integers. So if I want to write this as the ratio of two integers, this is negative 27. That's the same as negative 27 over 1, right? All the whole numbers, all the integers can be written as a rational number by just writing them as over 1. So this is 731 over 10's hundredths place. Okay, that's B. Okay, let's go ahead and continue. So this one, again, negative 24 over 1. And then for B, 357 over, there's 10's hundredths place, 2 zeros. Okay, so here A, 19 over 1, and then B, similarly, 841 over 100. Okay, so now we've expressed it as a ratio of two integers. What's an irrational number? An irrational number is a number that cannot be written as the ratio of two integers. So its decimal form does not stop and does not repeat. Okay, so it's like the number pi, right? If you guys are familiar with pi, 3.14, 159, and da-da-da-da, it continues, okay? It goes on and it never repeats. So it's very cool. Very, very cool. Okay, so how do you tell if something is rational or irrational? Okay, so if the decimal form repeats or stops, the number is rational. And if it does not repeat and does not stop, the number is irrational. So let's see here. We have these numbers, 0.58 and then 3 repeating. 47 hundredths, and then 3.60555125 dot dot dot. So which ones are rational and which ones are irrational? So rational would be 0.583 repeating, okay, because it's a decimal that repeats, that's the criteria, and 0.47 because it stops, okay, and then finally that would leave us with 3.60555125 dot dot dot. That would be irrational because it does not repeat or stop. Okay, so again, so look at these. Okay, if you need to pause the thing and tell me which one is rational, which ones are irrational. So rational, if you said the first two, you would be correct. Okay, and then irrational would be the last one because see the dot dot dots indicate that it continues and you don't see any repeats at this point. Okay, so how about here, square roots? Okay, so if the square root, so these just to go back really quickly, these numbers that we went over, these are called perfect squares. All these 1, 4, 9, 16, all these are perfect squares because you take the square root evenly. So perfect squares are rational. Why? Because they end up with a whole number. Okay, so and all whole numbers are rational. But the non-perfect squares or perfect squares that, you know, any other square roots are irrational. So square root of a number n where n square root of n does not equal an integer, a whole number or an integer, and a whole number actually. This is irrational. So let's say, for example, any square root of the prime number of a prime, that's irrational. Okay, because a prime doesn't have any factor other than itself and 1. Okay, so let's say here, square root of 36, a, that's just 6 times 6, so square root of 36, that's rational. What about b, square root of 44? So if you plug that in your calculator, how would you do that? You would put the square root key, right? You would have 44 square root, and then you get some crazy decimal, 6.6324332495807108. So dot dot dot. It doesn't end, so this would be irrational. Okay, so square root of 44, even though the 4 is part, it's 4 times 11. There exists a prime in there. Okay, prime is a factor. So a real number, what are real numbers? So take both the rational and the irrational ones, and that's the real. So let me show you this picture. Okay, so real numbers are everything here. So everything that's included, okay? Now you have the rational numbers. So real numbers are split into the rationals and the irrationals. The rational numbers are the ones that contain the integers, and the integers contain the whole numbers, right? And the whole numbers contain the counting numbers, okay? Then irrational numbers are not rational, and therefore they're not integers, not whole numbers, not counting numbers, okay? So also square roots of negative numbers are irrational. They're not, they're not real. So you cannot have a square root of a negative because is not real, right? So let's say, for instance, so what number could you multiply by itself so that you get a negative answer? Okay, there is a number, but it's not a real, it's an imaginary. So we just, right now, just think of any square root of a negative is not real. So for this one, A is not real. And then this would be real, okay? So then A for here, this would be real because it's -7. And then this one is not real. And we're going to get into, later on, we'll talk about that, why. So here we have a bunch of numbers. And we can list the whole numbers. They want us to list the whole numbers. So A, whole numbers. So the whole numbers from this list would just be 8. And that's it. Because that's it. It's the only one we can. The integers, you have -7, 8. And square root of 64 negative, that's equal to -8. So that counts. And that's it. C, the rational numbers, so that would be -7, 14/5, 8, not square root of 5 because that's prime, 5.9 because you can express that decimal as a fraction, and then negative square root of 64, which is -8. And then irrational would be square root of 5. And then E, real, would be all of them. Okay. All right. So now let's go ahead and talk a little bit about ordering of fractions on the number line. So here's the number line 0, 1, 2, 3, 4, 5, 7, 6. And you have -2, -3, -4, -5. Let's see if we can locate these on the number line. So 1/5 would be right to the right of 0. Okay, and then we have -4/5 would be over here to the left, right, in the negative direction. 3 is over here. 7/4 would be almost 2 because 2 is 8/4, right? Then we have -9/2. That's about approximately 4.5 negative. -5, and then 8/3. 8/3 is kind of like 2 2/3. So that's right there. Okie dokie. So how do we order decimals? Okay, so if you want to order the decimals, you just see you can think about it as money, right? You can write the numbers one under the other, lining up the decimal points. And if both numbers have the same number of digits, and if they don't, write zeros at the end of the one with fewer digits to make them match. 3, compare the numbers as if they were whole numbers, and then order the numbers using the appropriate inequality sign. So let's do some. Let's say we want to order 0.64 to 0.06. So which one's bigger? We have 0.64 and then we have 0.60. So this would be bigger, right? 64 cents is bigger than 60 cents. So let's see here, we have 3 places and we only have 2. So we're going to write this as 0.830 and then 0.803. So if we just look at them as if it was whole, this is bigger. Okay, how about this one? -0.1, is that greater than or less than or equal to -0.8? Now this 0.8 is larger, but remember that in the negative direction, this is less, right? Because on the number line, -0.8 would be here and -0.1 would be there. So, so this one is to the right, so it's greater than. Okay. Similarly here, so if you have a -0.3, -0.5 is to the left of it. So -0.3 is actually greater than 0.5, -0.5. Okay, so that's it for this section. You can do odd again, or you can do every other odd. It's up to you. Honor code, honor system. You really just, it's up to you. More practice, the better. If you can do them, go ahead and do them. The more you practice, the better you will get at this. Okay, so I will see you guys on the next video. Happy studying and good luck.